So in the previous videos we seen the push operation how to use, and along with the examples also we seen. Next one is the popping from the stack. So that is how can we perform the pop. Already we know that pop is exactly the reverse operation of the push. So here, so that means push, it helps to push the content onto the stack. Pop is nothing but retrieve the content from stack to the CPU registers. So that means exactly we can understand here, it is the movement from data to the move towards the source towards the destination. So here also it is same. When you want to write the pop operation, we need to use only the direct memory addressing mode only. That means we need to use only the memory addresses. We can't use the registers. For example, already I said pop space 3 means it is the valid. If you write pop space R3, this is the invalid. We need to write only the memory address of the respective registers. So let me to explain with one example here. So this example, so what is there? Examining the stack and show the contents of the registers and stack pointer after the execution of the following instructions. All values are in hexa. So here also is asking like that, what will be the content of the stack and what is the address of the stack pointer we need to write. So what is given the expression here, pop space 3 and pop space 5 and pop space 2. So that means it is meaning like that, pop space 3 is nothing but pop stack into R3. So this is the pop stack into R5, pop stack into R2. That means I need to perform the pop, that means I need to store the contents to the R3 and store the content to the R5 and store the content to the R2. So in this example, they given the sum of the values here. So already I said, when you are switch on the computer, so first initial value address of the your stack pointer, it will be 07 only. So 07 onwards, that means 08 will be the first memory location to hold the first data. So that means here starting stack pointer. So here they given 0A starting address 09A and B. So here the sum of the contents are there. Here they given the 54, F9, 76, 6C they given. So that means this is your they given the data itself. So already I said stack pointer is nothing but it holds the memory address of the top of the element. So this is the memory address. So this is your the respective content. So in this content, which one is the maximum top of the element? A top of element means 54 is that it is in the top position. That's why we are calling top element. So what is this address? 0B. So this address only it is going to held by the stack pointer only. So after pop 3, is nothing but once it execution of the first line. So what it will happen here? After pop 3 is nothing but what will happen? It is going to remove the first element. So what is the first element here? 54. So that means 54 it will remove. So remove in the sense I can show with a small example. This is your the RAM. So that means this is your stack. Here I am performing the push operation. So push is nothing but it is increasing the length of the stack. When you are performing the pop operation, that means this is your pop. When you are performing the pop operation, that means it will remove the data from the RAM. So once it remove the top of the element here, this memory address is going to vacant. It doesn't have any data. So when it remove the second data, again it will get vacant. So what is happening here? It is for length of the stack, it is going to get decrement. So similarly here also it is same. It is filled with the some values. When you perform the after pop 3, that means first element 54, it will remove. It will move towards your some other CPU register. That means it will get vacant in the first element. Is it clear? If you remove the first element here by using this instruction, what is the top element here? Top element means F9 will be the top here. So what is the address? 0A. That means stack pointer it holds the address of the top element. That means in this execution line, stack pointer address will be the 0A. Similarly, when you perform the pop space 5, at the time what will have after pop 5, what is the first element here? F9. So here it will remove the F9 this here. It will retrieve the data F9 to the some other CPU register. So that means I can say it will restore to the R5. Then what is the top element here? 76 is the remaining. What is the address? 09. So stack pointer hold the 09. So similarly, after pop 2 is nothing but What is the top element is 76. 76, once you perform after pop to 76 is it will move towards the R2 register, because 2 stand for the R2 register. It will copy towards, it will move towards the R2. Then what is the left here? 6C is left. So what is the top element? 6C itself, the only one element. This is only the top element. So what is the address? 08. So stack pointer address will be the 08 only. Is it clear? So this is also similar as over the push operation. So that means first here they return the content, all content. So line by line execution, pop 3, what will happen? So this is going to show the content of the, this is your the stack, and the respective top element address is held by the stack pointer. So similarly in the second step and the third step, because he given only the 3 pop operation is nothing, but I need to show only the 3 iterations of the 3 steps. So this is very, very important. In your exam they will give the small program. You write the content of the stack. Stack is means you need to write the content here. Along with you need to write the values of the stack pointer. This is very, very simple, but try to understand how it is going to work. Is it clear? So one more very, very important, that is the next one is the upper limit of the stack. So what will be the upper limit of stack? So this is a very, very important concept. So before going to start, first you need to understand this is the internal RAM structure. Already you know that. Is it clear? So in default case, you know, from the address 08 up to the 1F, this is the range, or this is the memory allocation of the stack also. Is it clear? Sometimes what will happen, so this count is 24 bytes already I said, because this is the 8 register means 8, again 8 16, again 8 means 24 bytes of stack. Sometimes what will happen, sir, instead of using the 24 bytes, I want to use the more than 24 bytes. At the time, how can I do? So at the time, is it possible to go for the again higher range? This is one option. So that means instead of the 1F here, I want to go, is it possible to go for the 202F, sir? That is the valid question. But here what will happen, when you are moving from, when you want to access the 20 to 2F memory location byte addresses, but we can't use this section, because this 20 up to the 2F byte memory address, this section, this area, this is the user can't access it, because this is purpose is they use for only the bit addressable RAM. This is fixed. It is not the user available. Then how can I do here? Instead of using 20 and 2F here, you can use 30 up to the 7F also in the stack also. That means instead of this range, up from the 30 up to the 7F also, you can use for the stack also. So how, but question is, sir, every time you said stack, whenever the switch on the microcontroller, always it holds the 7 only, sir. But in programming part, how can I do that one? So for this one, we can see the one more example. So here few points are highlighted. Just I will go through it once. 08 up to the 1F. This is the internal RAM. It is used for the stack. This is already we know. 20 up to the 2F. This is reserved for only the bit addressable memory. Is it clear? But is not the user available. So what is the last option? Already I said. Only if you want to use more than 24 bytes, is it clear? At that time we can go for 30 up to the 7FH. But how can I write this one? By using the one of the instruction, that is the move space SP. SP stands for stack pointer hash. This is the double X. Double X in the sense, if you want to write any particular memory address in between 30 up to the 7F, any one of the, something like instead of 30, if you want to access 35, at the time you can write the 35 here. That means instead of the 7 at the initial value, it will take 35 onwards. So this is the concept. I will explain with the one example here. So here also programming, show the stack and stack pointer for the following instruction. Again he given the program, we need to write the content of stack as well as the stack pointer. So what is given here? Move space SP stack pointer comma hash 5FH. So that means 5FH, it is also available in between the range of 30 to the 7F. So here I am using this 5FH. So here what will happen? Make RAM location 60 as the first stack location. So already we know that whenever you are going to switch on your microcontroller, 07 it is going to hold the memory address of the stack. Next one is the 08. That means 08 will be the first data allocation. So similarly here also 5fh it will be the initial address of the stack pointer. So after the 5fh, what is the next one? 60 is the next address. That means 60 is the first memory location to hold the first data. Is it clear? So already you know that in the first some classes I explained in hexadecimal number 00 up to the 0f. So that means 0f means 15. After the 0f, again it will increase by the MSB bit, means again it will become 1. Again this sequence it will repeat. That means it becomes 10, 11, 12 and so on 1f. After the 1f, what is the next one? Again MSB bit will get increased. That means it becomes 2. Again this 0 to f sequence it will repeat, means 20, 21 so on up to the 2f. So similarly here they given the 5f. So what is the next number? 5f means obviously what will happen? 5 it will get increased by 1, means 6. Again sequence will repeat, means 0, 1, 2, 3 up to the 6f. Next one is the 70. So that's why what will the next byte address? This was 60. 60 will be the first. It is going to hold the first data. So what will happen here? Some more instructions we can see. Move R2 comma hash 25. That means 25 I am loading to R2. 12 I am loading to the R1. 0F3 I am loading to R4. Already I explained in MSB bit, if you are writing the A, B, C, D, F, any one of the character, first you need to add the zeros. Then only it is a valid instruction. If you remove the 0 here, it is the invalid. Is it clear? So here the sum is written the push 3 instructions. Push space 2 means this is the pushing the R2 content. Push the 1 means pushing the R1 content. Push 4 means pushing the R4 content. So how to write the content here? So already I said starting address of the stack pointer in program itself he given the 5f. Is it clear? In program itself he given here the 5f. That's why here the starting address of stack pointer will be 5f. So what is the next address? 60. That means 60, 61, 62 and 63. Is it clear? And what is the first data? Obviously it will store the next memory address of the initial. That means 5f next means 60. When you perform in the push 2 means it is the direct memory address of the R2. So what is the content? 25. This 25 it is going to store in the here 25. So 60 is the first memory address. So 25 it will store here. So which is the top element? Only one element is there. So this itself the top element. So what is the respective address? 60. So stack pointer it will hold the address of the top element. So what is the address here? 60. That means stack pointer address 60. Clear? So next one is the push 1. Push 1 means push the content of the R1. What is the R1? 12. So this 12 content it is going to store in the second step. So what is the address? 61. So that means it will increase towards the top side. When you execute this second instruction push 1, at the time 12 is going to appear in the top of the list. So which is the top element? 12 itself the top element. So what is the address? 61. So stack pointer address will be obviously 61. Similarly push 4, when this instruction is going to execute here, 4 means this is the R4. What is the content? F3. F3 is going to store in the stack. So what will happen? After the push 4 here, your F3 is going to store in the again the next memory address, means 62 address F3. So what is the top element? F3. What is the address? 62. So stack pointer address will be the 62. Is it clear? So that means here you need to understand your stack always it holds the 07 memory location whenever you are going to switch on the microcontroller. But 07 next byte address, that is the 08. So 08 onwards it is going to store your data. Sometimes what will happen, if instead of 08 up to the 1F range, if I want to more than at the time we need to go for the 302 up to the 7F range, we can use it. Some of the examples they will initially they will give the sum of the address here. So randomly they will give. So based on this one you have to show the respective memory address increment here, and respective data also you need to show the stepwise step. This is very, very important. In our exam they can ask something like, what do you mean by the stack? Define the stack. Is it clear? How to use the push and pop operation? Show me the example, means you need to write the some theoretical. Is it clear? Otherwise they can ask, they will give the some program, they will also show me the content of stack as well as the stack pointer. So at the time you need to write the answer like this. This is very, very important question in the third module. Try to make the practice. Thank you.